Alright, we'll talk about potential relays today. See if we can't take some of the mystery out of it. Here's a potential relay. Potential relays are hooked in conjunction with a start capacitor. I already did a video on run capacitors. You need to know how to check a capacitor, and you need to know about motors before you watch this video. So if you hadn't watched the video about motors or capacitors, go back and watch them. What's the difference between a run capacitor and start capacitor? The one on the right hand side is a run capacitor. It's designed to stay in the circuit while the motor is running. The one on the left is a start capacitor. It's designed to get the motor started and then kick out the circuit. Since this one stays in the circuit, it'll get hot, so it's filled with oil. This one has nothing in it. Again, run capacitor stays in the circuit, start capacitor doesn't. So that is the whole purpose of potential relay. And we need to make sure we understand that before we get started on this motor. The potential relay has one purpose. It gets the start capacitor in the circuit on startup, so the motor starts, has real high starting torque. Once the motor kicks up and runs, the start capacitor gets kicked out of the circuit with the potential relay. So that is the point of it. Now, with the potential relay, I'm going to draw one. We need to know some connections on there. There are three connections we need to familiarize ourselves with. 0.5, 0.2, and 0.1. 5, 2, and 1. And they're going to be on here. You look for them and find them. There's 5, there's 2, there's 1. Now, whichever one you're working on may be totally different, but that's the ones we are worried about. 5, 2, 1. In between 5 and 2 is your call for the relay. Between 2 and 1 is a normally closed set of contacts. Remember that. Between 5 and 2 is your call. Between 2 and 1 is your normally closed set of contacts. Now, how is that wired up? Let's draw a contact in here. Here's one side of power. There's the other side of power. We just call it L1, L2. And again, you need to go back to the other video to learn about motors. Common goes to L1, run goes to L2. So if we close L1 and L2, it would be energized from the run winding only, but that wouldn't be enough start torque to get this compressor running. So you'd have to have your start winding. The start winding is going to assist the run winding and getting the motor started. Once you get started, the potential relay is going to drop the run winding and the start capacitor out. So let's put a start capacitor right there. Start capacitor. Very simple to wire this up. Get some color going on here. Number 5 goes to the same side of power as your common. So wherever your common wire of the compressor, whatever side of the contact it goes to, run number 5 to it. That's simple. Your start winding off your compressor goes to terminal 2. Then you come off of terminal 1, go to a start capacitor, come off the start capacitor, and go to the other side of power where your run should be at. So again, very simple. Number 5 goes to the same side of power as your common did. Common on a compressor is usually black. So you got this contactor here. A black wire is going there. You would run number 5 to the same side as that black. The start winding goes on to terminal 2, I'm sorry. The terminal 1 connects to your start capacitor. Start capacitor goes to the other side of the contactor, which should have your run winding on there. So how does that work? This is what kind of confuses a lot of people. This is what confuses people. Alright, contactor closes. Boom, boom. Power goes through here. And initially, we have a circuit through the run winding. So run winding is energized on startup. We also have a circuit comes through your start winding. It goes through the normally closed set of contacts, through your start capacitor, and to the other side of power. We have to have a good understanding of electricity. You have to leave one side of power, go through your load, and go to the other side of power. You don't come through your start winding and go back this way. You start in here, and everything is trying to go here. So when we start in L1, we go to common. We go down through run, that's a complete circuit. Run wind is energized. We come through start. Start goes through normally closed go through the start capacitor, that's energized. So now, this motor is up and running. And remember at the beginning of this film I said your start capacitor has to get out the circuit. So this start capacitor may be 100 and something microfarads. So it is a real big boost to the start winding. It energizes the start winding, we up and running, now we need to get it out of here. Now what happens, a motor, is, if you know anything about it, just like a generator. Inside of here is your rotor, and that rotor's turning. And as it turns, it actually creates electricity, just like a generator does. That electricity back feeds 5 to 2. That back EMF, is what energizes the potential relay. So you may have a compressor that's 208 volts, but your pickup voltage is going to be a lot higher. It may be 280, 300 volts, depends on what it's calling for. After this motor gets up to speed and running, the rotor goes to turning, you generate a back EMF, it energizes 5 and 2. When 5 and 2 is energized, the normally closed opens up, which takes the start capacitor out the circuit, and now we continue running without the start winding in there. And that's all it is to it. Now, you're not going to see them without a run capacitor. So what happens, you just come off of 2, go to your run capacitor just ties in here. So what happens on startup, we use this circuit. Once this opens up, this circuit is now irrelevant. Now we're left with a permanent split capacitor motor. We use the start capacitor to start. Once it starts, this kicks it out, and then we use the run capacitor to keep it running. That's what we call a capacitor start, capacitor run motor.